Everyone, my name is Atharva Dhanorkar, and in this video I am going to explain about the Stern-Gerlach experiment. So this experiment was initially performed by Oth Stern and Walter Gerlach, and the main conclusion after this experiment was that the electron has their own spin. Initially, it was known for its invention or the discovery of the spin gained have by an electron. So, introduction conducted in 1922 by Oth Stern and Walter Gerlach. This was demonstrated quantization of an angular momentum of the electron. First, evidence of electron spin. So for this, they have done an experiment on a experiment studied for studying the behavior of an atom in a non-uniform magnetic field. In this, they are going to take an electron of a single electron, and they were going to put it on a magnetic space, and they want to just check what the deflection it will do after going in the space, magnetic space, and determine the magnetic moment given continuous or the distract pattern. As they are going to give the continuous flow of a beam or a atom, number of atoms through a magnetic field, they want to see the deflection on the particle, which is going to give a certain pattern or display a random pattern or a prop pattern. So the experiment setup, they have first of all they had selected a atom of an silver. The silver atomic number is 47, as its configuration is 2 18 18, and the one which was in the outermost shell. So they have chosen a silver because the outermost shell of its was very easy to it was very easy to take it out, because they have to only give the plenty amount of heat to the silver, as it was easy to take out the last outermost atom from it. We have cause after coming out from its outermost shell, the last atom does not behave like a diamonetic, or like oxygen or N nitrogen, because if oxygen atom comes out from it, it can be a diamond, O2 or N2. But Ag atom, it behave like a more like noble gas, so it does not react with easily react with any other substance or atom in the surrounding. Now yes, silver atom heated to form a beam passes through a slit. So after heating, they have taken an oven, and in the oven they have placed the silver, and they heated up to 1000 degrees Celsius, and then the beam of an atom they will show a beam of an atom which will go through two slits, slit 1 and slit 2, just to give a certain direction. So the direction or the beam, they want to decide the direction of the beam. So it was very random, it should not go in any random position. So it slit was just to give a direction to the beam which was going to come out from the oven. So they after the beam passes through both the slits, they are going to place a non-uniform magnetic field applied through in the environment. After this beam will come, they have put a non-magnetic field throughout it. So they had then after detector placed recording the impact of points. After the beam come from the magnetic field, they just want to see the pattern, how it will be. Expected was only random pattern, as they were not knowing, but they come to know after the execution of the experiment. So this is the main setup for the our experiment. As you can see in the place 1, it is an oven, and the slit 1 and slit 2 over here. Now you can see a blue beam coming from point 1 and passing through the slits from point 2. So this is oven, this is slit 1, slit 2, and it is the beam of a silver Ag atom. Okay, so this is a magnet, two magnets. Basically these two magnets were there to create a magnetic field, just not for a magnetic field but also a non-uniform. It was demanded because they want to see how the beam will react after coming in the non-uniform magnetic field, and they have achieved it. They have taken a magnet with a sharply edged corner and other with a concaved shaped, so they have a shape difference, so it was easy to make a non-uniform magnetic field. So the expected beam pattern was just it will come slightly a straight line, but it was checked after the experiment that the beam has split it into 2 points, point 4 and point 5, and they have done a 2 points in the slit, which was not expected. So classical prediction was the random magnetic orientation, and the expected was the continuous spread on the screen. They thought that after the beam come from the magnetic field, it was a random spread on the screen. They were not expecting the two specific 2 points to be printed as a pattern. It was very unexpected for them. And the random magnetic orientation, as we had talked it about. So quantum prediction was angular momentum is quantized and the spin value was plus half or minus h by 2, sorry, plus h by 2 or minus h by 2. Orientation is the spin. Basically orientation is the spin of the atom which it have. There is basically only two spin, up spin and down spin, which is also called as plus h by 2 and minus h by 2. So due to that, they have only two significant points which we can see and which are printed on the slit. It was due to angular momentum is quantized, because it is quantized, and the spin value as you can see, plus indicate upward spin and minus indicate downward spin. That's why they wanted to take only single atom. So they have taken silver atom, cause the silver atom does not react with the any other component which we have like this. If we will take a single atom, other compounds, so it can react with other oxygen or this anything around our experiment setup. But the Ag atom was more likely to behave as a noble gas, so it was easy for us for doing experiment with it. So the actual observation was two clear spot observed. As we can see, point 4 and point 5 are the two clear observation we have found after the pattern we have seen here, and no continuous band, and confirm a spin quantization. As we have talked about spin value, it has only two spin value which has given a two distinct spots. So two clear spots observed, yes. No continuous band. They were thought it was said that it will spread anywhere, so it will be a random pattern or a continuous band, as it was continuous flow of beam through here, but it was only 2 points as printed on the slit, and it confirms spin quantization. Now interpretation: splitting due to electronic spin. So interpretation after the experiment done, they thought that it is due to the splitting due to electron spin. It was cause electron spin has only upward up spin and down spin, and we have got only two spots, so it was very obvious that it is due to electronic spin. And electron align parallel or anti-parallel to the magnetic field. As we know that after the electron, the one atom through the magnetic field, so due to its magnetic momentum, it was behaving like a tiny magnet, and the beams which were going inside this magnetic field was acting like a tiny magnet. And most probably, if the upward, as in the in the following diagram. It's upward is north pole and downward is south pole. So every atom which has gone to upward most probably have the south at the up and north at the down, and vice versa. So due to this behavior of the atom of like tiny magnet, so it has spotted two spots. And parallel and anti-parallel, due to only two spins we have, so it has to be only two distinct points, as the interpretation was a straight line from here. But as you can see, it was that the distance from these 2 points and in the center was equal. If these 2 points, distinct 2 points, the distance between them and the midpoint, from the midpoint these two points distance was equal. Yes. And significance, prove that in intrinsic spin, intrinsic, it means the inherent behavior of an atom after going through a certain space. In this experiment, a certain space was a magnetic field. After going through the magnetic field, it was an inherent quality of the atom to for its spin, inherent spin. Foundation of a quantum mechanics and quantization of computing. And it was, in that time, it was big discovery or a big experiment to be done for finding out the spins. The spin also affects the magnetic field, and it can also be have some different outcomes with the yes. The application for this experiment is MRI, quantum computing. We are using this technology or the outcome conclusion of the technology in the MRIs, spin electronics, and quantum computing, etc. is the applications. And for the conclusion, angular momentum is quantized, and Stern-Gerlach experiment shaped modern quantum theories. Yes, as per the experiment, we are also using this concept now also in MRIs, quantum computing, and many more things. And this also angular is also tell that the conclusion is angular momentum is quantized. So this was the all happening or the conclusion of the Stern-Gerlach experiment in this video by me. So thank you.